So what topic we were discussing? Yes. So we were talking about functions, correct?
Yes, sir.
So we were discussing functions. Can you see the screen?
Yes, sir.
Yeah. So we were discussing about functions and what is a function from A to B? Function from A to B is a relation from A to B such that for every element in A there is unique element in B which is related. Right, then we discuss about one function. So what is a one function? F from A to B is one. Right, one-to-one function if two elements in domain are distinct, then their images are distinct, or if images are same, then pre-images are also same. Right, this is what one function we know. What is onto function? F from A to B is onto, right? If for every y in B, there exists x in A such that fx is equal to y. For every element in codomain, we can produce pre-image in domain. If it is possible, then only we say that function is onto. If it fails for some element in codomain to produce pre-image in domain, then we say that function is not onto. So what is a bijective function? What is bijective function?
Function which is one and on both.
Right. If f is 1 and onto, this is the function is bijective if it satisfies both 1 and onto condition. Also, we saw that there is a bijective function from natural numbers to integers. Also, we discussed a bijective function from R2 to R2, plane to plane, right? Correct? Do you remember this?
Yes, sir.
If we define function from R2 to R2 by fxy is equal to ax plus by cx plus dy, where AD minus BC is not equal to 0, right? Then we saw that f is a bijective function. And we discussed this in detail, right? If you remember, we already discussed this key. There is a bijective function from R2 to R2. Right? Also, we saw that if A and B are two sets, suppose A and B are two sets, then the number of elements in set A and number of elements in set B is equal if and only if, when we say that two sets have same number of elements.
And there is a bijection.
If and only if there is a bijection. There is a bijection f from A to B. Right, so if you can produce a bijection from A to B or B to A, then the sets have same number of elements or same cardinality. Right, so all these points we already discussed, correct? Yes. Any doubt in this? No doubt. Okay, now just think about a is equal to 0 comma 1 and b is equal to 3 comma 7. Can we produce a bijective function f from 0 comma 1 to 3 comma 7? Question is clear? Yes, question is clear. What the question means?
Yes.
So we are given two intervals 0 to 1 and 3 to 7. Can you produce a bijective function from this interval to this interval? Right.
Yes.
Suppose answer is S. If answer is S, then what is the conclusion?
Number of elements between 0 and 1 is equal to the number of real numbers between 3 and 7.
Right. We can conclude that number of elements in interval 0, 1 is same as number of elements in interval 3 to 7. Correct? Fine. Now, next question I would like to ask is, because these are big questions and which we are going to attend these questions. Can you produce a bijective function f from interval AB to interval CD, any interval to any other interval? This is a question. Can we produce a bijective function f from any interval AB to any other interval CD? Right, so do you understand what is the meaning of interval? Now, third question, which is again a big question. Can we produce a bijective function f from any interval to set of real numbers, whole real line? Okay, read again all these questions and then we'll try to find answers to these questions. That will be our next aim. First question is clear.
Yes.
Right. We are given two intervals. Can you produce a bijective function? Now, second question is you are given any two arbitrary intervals AB and CD. Can you produce a bijective function from this interval to this interval? Open intervals, only endpoints are excluded. And third question is any interval to real numbers, set whole real line. Can you produce a bijective function? Right. If answer is yes, then what is the conclusion? What is the conclusion of third question? Do you understand? If answer of third question is yes, then the number of elements in interval, small interval, is same as number of elements in whole real line. This is a interesting thing, right? Correct? Okay, so find a bijective function. Let us start with from 0, 1 to 3, 7. Whatever is interval doesn't matter anyway. Correct? Find a bijective function from interval 0, 1 to 3, 7. So how to find? Let us see the figure which I am going to draw. Then you can understand what is a natural way to find. Okay, suppose this is x-axis, this is y-axis, and you know graph of a function, correct? What should be the domain in this case? What do we expect? What should be the domain? What is the domain?
0 to 1.
0,
1.
Right. And what we expect? What is the codomain?
7.
3 to 7. Suppose we are able to find a bijective function from 0, 1 to 3, 7. How will be the graph?
Linear.
Right. So we expect that range of f is 3 to 7. This we expect, and f is 1, 1. This we expect. X is 1. We want bijective function means function should be 1, 1, and range of function should be the codomain 3 to 7. Right. This is what we expect. Okay. Now can you draw the graph so that it is a graph of 1, 1 function, and it will cover entire codomain, right? Can you draw any such graph? Okay, what are the coordinates of this point? What are the coordinates of this point? 0, 3, right? What are coordinates of this point? 0, 7. What are coordinates of this point? 1, 7, correct? What are coordinates of this point? 1, 3. So picture is clear now. Now can you draw a graph in this rectangle, which is a graph of bijective function? What are the simplest ways?
To draw a straight line.
Which straight line?
End points as 0, 3 and 1, 7.
Okay. What is your name?
Varun.
So what Varun is saying, just connect the diagonals. Connect the opposite corners of a rectangle. This is a one way. And will it be a graph of a function and one bijective function? What is another way? What is another way? You can join these opposite corners. This is also a way, right? Either you consider this red line or green line. Okay, we'll see this in detail, but first of all, try to understand what we are going to achieve. 3, 7, 0, 1. Okay. Again, same picture. I am just looking at same picture, right? So suppose I draw this type of graph. Will it be a graph of bijective function in second figure? Can you see
No,
second?
sir.
No, right?
No, sir.
No,
Because
sir.
first of all, this would not be one because there are two distinct points corresponds to same image, right? One more thing, this is not onto because for this point there is no pre-image or for this point there is no pre-image. These pink dots will not have a pre-image in codomain, correct? So this cannot be bijective function, and therefore we have other than these two straight lines. Can you have any other choice different from these two straight lines?
Sorry, sir. Which points will not have a pre-image? Can you please show again?
In second figure, if you look at this, see the second figure. Can you see the second figure?
Yes, sir.
In second figure, for example, if you look at this yellow dot, can you see yellow dot? Yes. In codomain.
Yes, sir. 0, 7.
No. Yellow dot is just below 7. Or let me draw the bigger figure so that you can see it clearly. Because the point is, what is the bijective function from graph? See this figure 3, 7, 0, 1, and our graph will be in this. So suppose I draw some graph like this. Is it a graph of bijective function? This is my question.
No, sir.
I know because there is a point here. For example, if you take this point in codomain y, this point do not have a pre-image. That is the problem, right? Because we cannot produce pre-image. For example, if you look at this point, what is the pre-image of this point is this. Pre-image of this point is here, but pre-image of this point does not exist because this horizontal line does not intersect with the graph, right? Moreover, this graph is not a graph of one function because there are two different points with same image. There are two different points in domain with same image in codomain, correct? So this graph cannot be a graph of one function. Yes, and simplest way to look at it, just look at the straight lines which join the opposite corners of a rectangle. Then these are the graphs of bijective function because you choose any point, corresponding point exists in the domain. If this idea is clear, then how to find the exact function? Explicitly, what is the function? Whose graph is this red line or green line? Right? We understand what we expect or what we are going to find. Yes. Okay, let us try to find a function which is whose graph is a straight line which joins the opposite corners 0, 3 and 3, 1, 7. Right? So suppose f of x Now the graph is straight line, so function is like this: ax plus b, degree 1, right? Because it is a linear graph, is a straight line, so we expect that our function is of this type ax plus b, but we don't know what are a and b, right? Such that initial point, what is initial point? Image of 0 is 3 and image of 1 is what? What will be image of 0 and what will be image of 3? What will be image of 1? If you want to get the function whose graph is this red line, what will be image of 1 then?
7.
7. Right? Image of 0 would be 3 and image of 1 would be 7. Function we want, suppose. But then from our function f of x, what is f of 0? What is f of 0? A into 0 plus b. That we expect that it should be 3. And therefore immediately we get value of b. B is equal to 3. Correct? Now f of 1 is equal to 7. This imply what is f of 1? A into 1 plus b is equal to 7. That means a plus 7 is a plus b is equal to 7. But already we found value of b, which is 3, right? So a plus 3 is equal to 7. That means what is value of a? What is value of a? 4. Therefore a is equal to 4. And therefore what is a function? Therefore f of x is equal to ax plus b is 4x plus 3. Is right. So now question is f 1 1? We found a function now. Is it 1 1?
Yes.
Is it 1 1? Yes, because suppose fx1 is equal to fx2. Suppose. Then does this imply x1 is equal to x2? So that means 4x1 plus 3 is equal to 4x2 plus 3. Right, because fx1 is 4x1 plus 3, fx2 is 4x2 plus 3. And equal means these two things are equal. So 3 3 cancels, 4 4 cancels. Right? That means if images are equal, pre-images are also equal. That means if pre-images are distinct, that means images are distinct. Therefore f is 1 1. Right. Second question is f onto? Is f onto? Is f onto? Is f onto or not? Let y belongs to codomain. What is codomain? Then can you find x in 0 1 such that fx is equal to y? That is, if it is possible, if answer is yes, then function is onto. Right? For every element in codomain, can you produce pre-image? And just look at this function, red line. Forget about this yellow line, green line. Just look at red line. Is it a graph of onto function? Yes. You choose any y from codomain. What is x? This is x in domain. F of x is equal to y, and corresponding point on the graph is xy. Correct? Ultimately, so what is image of 0 is 3, image of 1 is 7. If you choose another y, then we can produce x in domain 0, 1. Right? So in this way, for every y in codomain, can you produce x? So what is, so if x in 0, 1 such that fx is equal to y, that means what is fx? What is fx? 4x plus 3. That means 4x plus 3 is y. That means what is x?
Y minus 3 by 4.
Right, y minus 3 by 4. And is it possible to produce? And does such x exist in 0, 1? So since y belongs to 3 to 7, that means 3 less equal y less equal 7. So 3 minus 3 less equal y minus 3 less equal 7 minus 3. Am I right? That means 0 less equal y minus 3 less equal 4 divided by 4. So 0 by 4 less equal y minus 3 by 4 less equal 4 by 4, which is 1. Right? That means 0 less equal y minus 3 by 4 less equal 1. That means 0 less equal x less equal 1. That means if you choose any y in 3 to 7, then x, therefore for every y in 3 to 7, there exists x, which is y minus 3 upon 4, which is in between 0 and 1, because this number is necessarily in between 0 and 1, such that f of x. But what is f of x? Y minus 3 by 4. X is y minus 3 by 4. Right? But what is, by definition, what is f of x? 4 into
Plus 3.
x plus 3. But what is x in this case?
I minus 3 by 4.
Y minus 3 by 4. X is y minus 3 by 4. So it is 4 times y minus 3 by 4 plus 3. So 4 get cancelled. And what is it? Y minus 3 plus 3. 3 get cancelled, y. And therefore the x which we have produced is actually the pre-image of y, because if we apply, for example, if you look at particular case, if I choose y is equal to, you choose any element 6, is it in the domain? Right, 6 is in the codomain. What is of 6? What is pre-image of 6 now? Can you tell me
3
this?
by 4.
3 by
What is pre-image of 6 is x, is y minus 3 by 4. That means 6 minus 3 by 4. What is it? 3 by 4.
3 by
So pre-image of 6 is 3 by 4, which is in 0. So for every element it is true. And so can we conclude that hence f is onto, and therefore f is bijection because it is 1 1 and onto. Correct? Okay, so what you understood now, we can produce a bijective function from interval 0, 1 to 3, 7. But is it the only function? Can you produce any other bijective function? What is any other bijective function? Yellow line. Right. I just found function which is a red line. Now you can produce a function whose graph is yellow line. Correct? Or you can also produce another function which is not straight line, but that is difficult in some sense. You can produce non-linear also, which is not a straight line in this way. Right, but the straight line is the simplest way. Is it clear? Any doubt in this? Is it clear?
Yes, sir.
Yes.
Now I am going to give you some exercise for you. Find bijective function f from -1 to -1, 1 to 3, 10. Alright, so you try to find this in similar way. Now next question we want to discuss is if a less than b, c less than d, then find a bijective function f from ab to cd. Do you understand the question now? Question is clear. Question is clear. What is the question? What is the question? Question is domain is interval AB, codomain is interval CD. Right, so that means codomain is on y-axis, domain is on x-axis, and what we want a bijective function from this AB to CD. Correct? You understand? That means graph of the function must be inside this rectangle. Is it clear?
Yes.
Yes. Now, is it very easy now? If you understand previous example, just write down the coordinates. BD, A, BC, and here AD, coordinates of these corners. Right? What are the different ways to find a bijective function? So you can either find a function which joins these corners or function which joins opposite corners. This is the simplest one. You may have many other. You can have function like this. You can have a function like this, which is a bijective function, or you can have a function like this, which is also bijective. But these are difficult. The straight lines are simplest one. Right? You can find anyone, either green line or yellow line, whichever you want, you can find. Suppose f from AB to CD is a bijective function which joins bijective function whose graph joins the points AC, BD. Then which function we can choose? We should choose the easiest function is a straight line, degree 1 polynomial, right? So let fx is equal to alpha x plus beta. Suppose this is a function such that the its graph contains point a comma c. That means f of a. What should be the initial value of function at a? What we expect
C.
c, and what we expect value at b,
D.
right? Because we want a function whose graph is this green line. That means which joins this point and this point AC and BD, and therefore we expect that value of function is at D. You can also find a function. Remember this key. You can also find a function g is equal to gx is equal to alpha x plus beta, and g of a is equal to D, and g of b is equal to c. This is another, right? That means graph is what? Yellow line. If you find function g, then its graph is a yellow line. Either you find this function or this, no problem. Both are bijective functions, right? Okay. Then if f of a is equal to c, but by definition of fx, what is f of a? Alpha a plus beta, which we want this to be c. And what is f of b? Alpha b plus beta, which is d. Right. So what are known quantities and what are unknown quantities? Expression 1, expression 2. What are known quantities and what are unknown quantities in equation 1 and 2?
AC and BD are known quantities.
Right, because intervals are given. You are given intervals A, B, C, D. So A, B, C, D are known quantities. And what are unknown quantities?
Alpha and beta.
Alpha and beta are unknown quantities. Once we get values of alpha and beta, we are through because we get the function actually. If you recall the previous example, we wanted to find a bijective function from 0, 1 to 3, 7. Unknown quantities were a and b, and we determined values of a and b, and we actually get the function 4x plus 3. So this is the exact value definition of a function, right? A and b were unknowns. We found them. So similarly, in this case, alpha and beta are unknowns. Once we get values of alpha and beta, we get exact definition of function. But these two, note that A, B, C, D are known quantities, right? Why these are known quantities? Because A, B, C, D intervals are given. So equations 1 and 2 are two simultaneous linear equations, and alpha beta are unknown, right? So alpha and beta are unknown. So equation 1 and 2 are two simultaneous equations in two unknowns, alpha and beta. and therefore can we solve them? Can you solve them?
Yes.
Yes, we can solve these two equations, and therefore what are the values of alpha and beta? We get, see the equation 1 and 2. If we subtract a second from 1, beta will get eliminated, and what is value of alpha? What is alpha? Just subtract 1 and 2. Beta will
C
get
minus D upon
C
A
minus
minus B.
A minus.
C minus D upon A minus B. C minus D upon A minus B. Very good. And what is value of beta? What is value of beta? Solve for alpha. Solve for beta. Right. That means multiply first equation by B, second equation by A, and subtract. Right.
C minus A upon D minus B.
Multiply first equation by B, second equation by A, and subtract. So what we get? BC minus
AD upon
divided by what? B minus A.
B minus A.
Or other way I can AD minus BC divided by A minus B. Right, so let us call it as fourth. And therefore, what is f of x? What is the exact definition of function? Alpha x plus beta. What is alpha here? C minus D into x upon A minus B plus AD minus BC divided by A minus B. Right, or 1 upon A minus B C minus D into x plus AD minus BC. Right, this is what a exact definition of a function. You can have other form by just simply manipulating these numbers, right? Then if this function f from AB to CD is a bijection, can you prove this? Try to write down the proof that this function is a bijection. And what is the importance of this expression? This gives a general formula. This function, do you realize this? This actually gives the general formula. Somebody gives you intervals, you can immediately give him a bijective function. Am I right? Yes. Does it give a general formula?
Yes, sir.
Yes, right? Because for example, find a bijective function f from now can you find bijective function direct from 1 comma 3 to 5 comma 7? Just compare with the previous general problem. A is equal to 1, B is equal to 3, C is equal to 5, D is equal to 8. And can you tell me directly what is a bijective function? Right? What is a bijective function? C minus D 1 upon A minus B into C minus D times X plus AD minus BC. So what is A minus B? What is A minus B?
minus 2.
Minus 2 inside the bracket C minus D
Minus 3.
right?
3x.
The function is 3x plus 7 upon 2.
So what is AD minus BC? 8 minus 15. So minus 7, right? And minus outside the bracket there is minus, so it becomes plus. So 3 by 2x plus 7 by 2. Right, so this is a bijective function from. But is it the only function? You can find another. What is exercise?
Reversing the signs.
You check it. So find a bijective function f from AB to CD such that, because in the graph, in the picture I showed that a green line and yellow line. So you find the function whose graph is yellow line. In the previous case we found function whose graph is a this line, which green line. You find a function whose graph is yellow line. Correct. Find a bijective function f from AB to CD such that here I am expecting f of A is equal to D and f of B is equal to C. Right, means what? Graph will be yellow line. Yellow line means what? Value of function at A is D and value of function at B is C. This is what another way. Right, so this exercise you do the same process and try to find the function. Okay, let us go to the next. Find a bijective function f from AB to CD. So actually, question is same, just I am excluding endpoints. And right, if I define f of x is equal to c minus d upon a minus b times x plus ad minus bc upon a minus b, will the same function works? Will same formula work here?
Yes.
Right, so same formula works here because no problem, because what is f of a is c, but c is not, a is not in the domain and c is not in the codomain, so this will not create an issue. Or f of b is equal to d, but b is not in domain, d is not in codomain, so not a problem. So therefore what happens, this open interval goes to open interval. So this is a bijective function. So close or open doesn't matter, the same function works actually. Right. Fine. So, and therefore this is exercise. A bijective function f from minus 1 comma 1 to 0 comma 1. Find a bijective function g from minus 1 comma 1 open to any interval ab. So you think about these two questions. Is it possible? What is your answer? Is it possible? Is it possible to find a bijective function from 1 minus 1 1 to 0 comma 1? Is it possible? What is your guess?
Yes.
Yes, because we have already the generated formula to find bijective function from any interval to any other interval. So -1, 1 to interval AB, that is also possible. You try to produce explicitly what is these functions, right? Because you want to discuss very interesting problem. So let defined by fx is equal to upon square root of 1 plus x square. So is it a function or is it a well-defined function? Is it a function? Can you find value at every real number? Yes. Yes or no?
Yes.
Yes, right? Because we can, whatever real number is given, you can find value because denominator is square root, but denominator is not negative. So denominator is also well defined and is never zero. Correct? So it is a function, it is well defined, no problem. Is f11. Is f11. So let us check. Suppose x and y are real numbers such that their images are same, or if you choose distinct elements, check that the images are distinct. Then what we expect, suppose images are same. For oneness, what we expect,
Three images are the same.
three images are also
That's
x is
same.
equal. So let us check whether three images are same or not. Fx is equal to fy means what? X upon square root of x square plus 1 is equal to y upon square root of y square plus 1. Correct. Because our question is whether pre-images are same. Let us try to find. Now if we square both sides, squaring, what we get, x square plus 1 is equal to y square plus 1. Correct? That means now cross multiply x square into y square plus 1 is equal to y square into x square plus 1. Cross multiply. Further, what next? X square y square plus x square is equal to x square y square plus y square. Correct? Something get cancelled. What get cancelled?
X square y
So what remains? X square is equal to y square.
I
But
see.
x square is equal to y square. Can we say that x is equal to y?
Yes.
No.
No. In general, no.
No.
Right? Because x is equal to 1 and y is equal to -1. X square is equal to y square, but x is not equal to y. Right? If x is equal to 1 and y is equal to -1. So we cannot directly say that x square is equal to y square implies x equal to, but what we can certainly say is x is plus minus y. That is certainly true. Correct? So x is equal to plus or minus y. If x is equal to plus y, we are done. But now if x is equal to minus y, that means x and y will have opposite sign. X and y will have an opposite signs. Right? Will have opposite signs, and therefore x upon square root of 1 plus x square and minus y up, x and y will have opposite sign. X is equal to negative of y. That means y is x is positive, then y is negative. Correct? Am I right? Or if x is negative, y is positive. Is it correct?
Yes, sir.
That means x and y will have opposite sign. That means y upon 1 plus x square y square would have opposite signs. Am I right? Because denominators are positive, square root of 1 plus x square, square root of 1 plus y square. If x and y have opposite sign, and if you divide by positive quantity, still they have opposite signs. That means fx and fy would have opposite signs. What does it mean? If fx and fy have opposite sign, that means fx is not same as fy. Contradiction. Am I right?
Yes.
And therefore, why I get contradiction? Because if I assume that x is equal to minus y, then I get contradiction, and therefore what is the only choice?
X equals to y.
Therefore, x is equal to y is the only possibility. And hence, what is the conclusion? Thus, fx is equal to fy implies x is equal to y, and therefore f is 1, 1. Okay, so this is clear. This function is 1, 1 function. Right? Now, third part of this question is f on 2. Is f on 2. What is your answer? What is your guess? What is your guess?
No, sir, it's not on to.
Not on 2, because simple observation is, observe that
The square root is there.
square is greater than x square, right? And therefore square root of 1 plus x square is greater than x. And x upon square root of 1 plus x square. Actually plus minus you can say. Anyway, or I can say absolute value. That's fine. That means x upon this is less than or equal to 1 basically, or strictly less you can say. And therefore f of x is strictly less than 1 for all x. That means for the value of function for every x in domain is strictly less than 1. And moreover, it is strictly greater than -1, because if you see the square root absolute value, then you can check that if x is negative, it is greater or equal to minus. So, okay, in any way, value of function is strictly less than 1. That means, for example, if you take y is equal to 2 in codomain, this y would not have a preimage, because that means, therefore, f is not onto, because every value is less than 1, and for a number y greater than 1, it cannot have preimage. That is just simple observation. So if it is not onto, another way, alternatively, if y belongs to R and x belongs to domain such that y is in codomain and x is in domain such that fx is equal to y, then what is y? Then what, for what values of y it is possible to find x? Correct? For what values of y it is possible to find preimage x? That means which y's are in the range. So then what is fx? X upon square root of 1 plus x square is equal to y. Right? Solve this for x. If you try to solve this for x, that means x square upon 1 plus x square is equal to y square. So x square is equal to y square plus x square y square, and we want to solve it for x. That means x square minus x square y square is equal to y square, means x square into 1 minus y square is equal to y square. That means x square is equal to y square upon 1 minus y square. Correct? And therefore what is x? X has two possible choices. One, square root of 1 minus y square. And when it is possible to produce x? Provided this is a well defined. Well defined means what? Denominator is real number. When denominator is real number, when this is well defined, provided 1 minus y square is greater than 0. That means y square is less than 1. That means y square is less than 1 means what? Y belongs to -1 to 1. Am I right? Do you understand? Do you understand what I want to say? Yes?
Yes.
Right. So given any y in codomain, for which y it is possible to produce preimage, for those y which satisfy this expression, that means y lies between -1 and 1. That is therefore what is the range of this function? Can you tell me what is the range of this function?
-1 to 1.
-1 to 1. Very good. And now think about it. Next time we'll discuss this, continue this with this.